Welcome, my dear students, to the online lecture series of Metallurgy and Material Science. This is the introductory lecture of Metallurgy and Material Science course. As a human being, the materials play a very important role in our day-to-day life. Just look around your surroundings. You can see different types of material. The material may be plastic or steel or copper or cement. There are different types of material you can see around you, and materials are probably more deep-seated in our culture, and virtually every segment of our everyday life is influenced by materials. So for example, if you see your house or your cloth or your communication system or transportation system, everywhere we are dealing with the different types of material. So in this course, we are studying deeply about materials, and we already discussed about the preambles of this course during our live interactive sessions. This is the prerequisite of the course, and these are the course outcomes. We already discussed about that. Coming to the history of material science development, as a human being, during human civilization, actually we can divide our human civilization based on the material. And if early age human civilization is defined by Stone Age, and during Stone Age, actually we are using different tools for hunting using sharp-edged stones, and they mainly use stone for different applications. And so that time or period can be called as Stone Age. After some time, they started using different types of metals, and the Bronze Age started. The bronze is the alloy of copper and tin, and they collected it from the mines, and they used this bronze or any other metal for different applications, commonly for hunting applications. And next period is Iron Age. During Iron Age, they have started technologies to convert iron from the ore, and they used to use this iron for different applications. They developed different products using iron, and they use different tools for hunting, and they develop wheels, and for the human comfort they are developed different applications using iron. And the next period is Plastic Age. After, so the second one Bronze Age, and third one Iron Age, and fourth one is Plastic Age. And after Iron Age, different materials have been developed. Then Plastic Age came. During this Plastic Age, different engineering applications we use plastic. We are using different products using plastic, and laptop, mouse, mobile phone, everything. Most of our applications or most of our products are developed or manufactured using plastic. Then after Plastic Age, and the recent development is Silicon Age. For our electronic components, our electronic components are commonly developed using silicon or germanium. So we call this is Silicon Age. So we can see the human civilization from the Stone Age to Silicon Age. According to human requirements, the materials for a particular period have changed from stone to bronze, iron, plastic, silicon. So nowadays we are not using stone for any particular engineering application. We are using plastic or any type of metals for different engineering applications. So the materials day by day is changing. The application point of view, the material usage is day by day changing, and we are developing different types of materials. And when you take Stone Age or Bronze Age, early humans had across only few number of materials since they are only using naturally available material. They're only naturally available material. They are not developing material. They are only use naturally available material for different engineering applications. But nowadays, using different technologies, we are developing different materials according to the applications. We can alter the properties of the material by the addition of different substances or by using different process like a heat treatment process. So according to our requirement, for example, for making the nose of a missile, there is no naturally available materials available. So for that, we are developing a material for making the nose of the missile. So for particular application, we are developing the material. How can we develop? By studying the material science and the properties and the structure of the material, we can come to a relationship between the structure of the material and the properties of the material. And by studying this structure property relationship, we can alter the properties of the material by changing the structure, by altering by adding substance, or by changing the structure by the heat treatment process, etc. So the material scientists actually nowadays understand the relationship between the structure of the microstructure of the materials and the properties of the material. More than 10,000 materials have been developed with specialized characters to meet the needs of our modern and complex applications. So thereby we can develop any material with different properties. So scientists every day they are researching about the development of new type of material. So the development of any technology in any area is highly correlated with the development of material. There are many examples that the material play an important role for the technology development, because for a development of particular application or development of particular technology, material play an important role. So let us discuss what are the different influence of material on the development of different technologies. So you can see different high-end technologies used nowadays. The first one is the Intercontinental Ballistic Missile (ICBM). So this missile can go from North Korea to USA. It's the Intercontinental Ballistic Missile. So very long-range missile, and actually it can take to very high altitude, and then it can come back to the atmosphere from the very high altitude. So that is Intercontinental Ballistic Missile. So the main problem of high altitude or high range missile is that when it re-enters to the atmosphere, there is a chance for high friction between the atmospheric particle and the materials of the missile. And due to very high friction, there may be a chance of developing a very, very high heat over the surface of the missile. So for this, we need a material to protect the missile from very high temperature or very high heat. For that, we need to develop a material. So for that, mainly the high heat is developed on the nose of the missile, and in the nose area we are using different types of material. And commonly, actually the selection of material or the research about the material is very confidential, and the country is not revealing which type of material is used for particular applications. But commonly they are using reinforced carbon composite to cover the nose area of this type of ballistic missile and even rockets. So here, this application, the development of ballistic missile, every technology is related to the material. The high strength material at high temperature is very important for the development of this ballistic missile. Without that material, we cannot develop a high range missile like ICBM. So as you know, the Kalpana Chawla accident, when they are re-entering the space shuttle into the atmosphere, due to very high heat, the shuttle is collapsed and leads to the death of the Kalpana Chawla. So here also the problem is the material coating. So when they are re-entering, the material should have the capacity to resist very high temperature. So this type of material development is very important for this type of technology. Another example is Gslv Mark III. You know this space vehicle Gslv Mark III, and the main characteristics of this Gslv Mark III is very high payload. It can carry number of satellites, and so its payload is very high. So for that, we need an engine which can directly take liquid hydrogen and oxygen and combine them together to generate the thrust. So because of the very high payload, the conventional rockets are not possible to reach the outer atmosphere. So we need a hydrogen oxygen fuel for generating the thrust of this vehicle. So at room temperature, both hydrogen and oxygen is in gaseous state, but at a very low temperature called cryogenic temperature, this is very low temperatures, minus temperature, and during in that temperature, both the hydrogen and oxygen can be held in liquid state. So the material which will be required for storing this hydrogen and oxygen at a very low temperature is an important development for this cryogenic technology. You may know the Indian Space Research Organization already developed a cryogenic engine. So a cryogenic materials like the hydrogen and oxygen in cryogenic state should hold with a particular material. Some titanium alloys, some titanium alloys can hold this the hydrogen and oxygen in cryogenic range, and by development of this titanium alloy, we can develop cryogenic engines, and finally we can run this Gslv Mark III. So here also the material, the titanium alloy play an important role. So the material scientists constantly researching about different types of material for such type of applications. Another one is a popular product called Apple, and they are using aluminum alloys and copper ceramic metal metric composites and stainless steel for covering the Apple watches. And here gold is very the hardness of the gold is very low, but gold covering gives a good look for the watch. But we add gold ceramic, we make a composite with the gold and ceramic. We know ceramics is very hard, so by making a composite with the gold and ceramic, we got a very hard surface without any wear, etc. And of course, the aluminum alloys are also used to cover the watch. So this type of material actually developed for our products like Apple, and maybe in laptop also, Apple laptop also using aluminum alloys for making the covering of the laptop, and thereby they can reduce the weight of the laptop. So in different areas, we are using different high-end materials, and without these materials, the technological development in those areas are very limited. So this is the importance of materials. Another important application is in the electronics industry, the semiconductors. You already studied about the semiconductors, N-type and P-type semiconductors. and commonly semiconductors are developed using silicons. And these silicon semiconductors, very high purity silicon semiconductor, we add impurities into the semiconductors and we develop N and P type semiconductor. And here we need silicon with a very high purity, 99.9999 purity level is needed for making a very good semiconductor. And similarly, different types of materials are used in electronic industries to develop different chips and electronic components. So there also the material play an important role. Another area is automobile industries. Automobile industries are using different materials like high strength steel, uh, high strength steel with is used to make the body of the car, and they are making different materials with the high strength and low weight. By making a material, a car with a material with a high strength and low weight, they can make a car with a it can hold high impact loader, as well as they can make a car with a fuel economic high. So in different applications we are using different high-end materials, and for specific particular applications the material scientists develop a specific material. So for example, here the carbon reinforced composites are developed for this specific application. Here what is the main property requirement for this material? It should have very high strength at a very high temperature. That is the main property required for a material for covering the nose of a missile. So for that, by doing different heat treatment process, or by doing different by the addition of different substance on the existing material, we can develop such type of material. So material scientists constantly researching about this type of development of new materials for a specific application. So what is material science? So you already know what is materials. What is material science? The material science is actually investigating the relationship between the material science. To actually investigate the relationship that exists between the structure and the properties of the material, the microstructure of the material and the properties of the material. So this material science gives all the relation properties between the structure and the properties of the material. And another name is materials engineering. Materials engineering is on the basis of the structural property correlations, designing or engineering the structure of the material to produce predetermined set of properties. That is materials engineering. So material science only deals with the structure and the property relationship, but materials engineering using the materials to produce different engineering applications. Coming to the role of material scientist and the material engineer, the material scientist actually dealing with the material science. Material science is to scientists actually develop or synthesis new material. That is the job of material scientist, and the synthesis or development of new material is based on this material science. And but whereas the materials engineer is called upon create new products or systems using existing materials. So actually material scientists develop materials, and materials engineering what develop new products or system using existing materials, and or develop new techniques for processing the material. So that are the jobs of material engineer. Material science is actually developing new materials. So that is the role of material scientist and the materials engineer. Next one is we study material science. What is the use of studying material science? as an engineer, specifically as a mechanical engineer, um, basically the material sciences can be used in every branches: civil, mechanical, electrical, chemical. Anywhere we can use material science. So as an engineer, at one time or another, be exposed to create a design problem involving material. Maybe after your course, you may enter into an industry where you have to select a particular material for particular application. So selecting right material from thousands of material is an important decision for the development of any product. And the selection of material is basically based on three criteria. The first one is properties of the material. For example, for developing this pen, so as an engineer, your job is to design this pen. So while designing this pen, you can select different material. You can use plastic, you can use stainless steel, you can use aluminum, you can use copper, gold. There are different types of materials are available to create the body of this pen. So the selection of right material is based on the properties of the material. And if you need a pen with a very hard surface, then you can choose steel. So based on the property, it may be thermal property, or it may be magnetic property, or optical property, or mechanical property. So based on these properties, according to the requirements, you can select a particular material. So that is the first criteria for the selection of material for a particular application. And second one, deterioration of material properties. That is also very important. For example, if you want to select a material for the hull of a ship. So for selecting the material for the hull of a ship, the deterioration of the material is an important character, because the corrosion, every time this hull of the ship is coming in contact with the seawater, so the corrosion is very important. So to avoid the corrosion, we should select a suitable material. So deterioration of the material properties is another criteria for the selection of material. And third important criteria is economics. The cost involved in the processing of the material or making of the material, etc. Because as an engineer, we should optimize the cost and the other characteristics of the product during the design stage. We can select any, for example, we can create this pen using gold. But if we create this pen using gold, the economic aspect is, when we consider economic or cost consideration, this is not good. So we should select a material with a low cost. At the same time, should give very good properties. So these are the three main criteria for selecting a particular material for particular application. Next, we will see an example of a nano car. What are the different types of materials used in the manufacturing of nano car? So here we can see the bonnet and the body of this car is made with steel, and the bumper area is made with the plastic, and the tire is made with the rubber, and here we can see the glass materials. So there are different materials are used for the manufacturing of this nano car. So as a normal person, just when you look around this nano car, we can see different materials. But as a materials engineer, we will look into deep of this material. So this is just a macroscopic view of this material, different types of materials used in this car. Next, when we scale down into more deeper, Here I am taking this portion of the bonnet. I am looking the structure of the bonnet or the materials in this rounded area. Here we can see in the microscopic level, we can see this type of structure. And here you can see some dark areas and some white areas and some boundaries in the microscopic level. Again, if you scale down, we can see the atoms or molecular arrangement. Here we can see the atoms or molecules are arranged in a regular fashion. And again, if you go deeper, we can see the atomic, interatomic structure or subatomic structure, the electrons, nucleus, etc. And the atoms arrangements, there are 14 different types of atoms are arranged in a crystalline manner. So these are called crystal structures. So the arrangement of atoms in crystalline manner, there are different arrangements are possible, and there are 40 different arrangements are given in this picture. Okay. So when you look on a particular material, there will be a macroscopic level, then microscopic level, then atomic level, then subatomic level. Okay, so as a materials engineer, we are studying this level, the microscopic, atomic, subatomic level. Okay, so by studying the microstructure, we can find the relationship between the structure and the properties of the material. So throughout our course, we are using microstructure. Microstructure is nothing but it is the arrangement of internal components. The internal components are nothing but atoms or molecules. So what is the arrangement of atoms and molecules is the microstructure of the particular material. And of course, we are using another term that is called properties. A property is a material trait in terms of the kind of and magnitude of the response to particular external influence. For example, mechanical property, thermal property, or magnetic property, etc. So, what is the response of a particular material against a external influence? For example, if you are giving a force on a particular material, what is the deformation of the material? So that gives the different types of mechanical properties like Young's modulus or another different properties. And if we transmit some amount of heat, and in what velocity the heat transfer from one end to the another end of the material, that gives the thermal property of the material. So similarly, what is the response of a material regards to the external influence gives the property of the material. So in this course, we are actually studying the relationship between the properties of the material and the microstructure of the material. And by studying this relationship, we can alter the properties by altering the microstructure of the material. All these things actually we are studying in this metallurgy and material science. So the properties of the material actually depends on the atom molecules bonding and of course the microstructure of the material. So this microstructure and the property relationship is the one of the important and the central thing in the area of material science. So in this course, we will begin our journey by looking at the atomic structure, more specifically the crystal structure of the material. First we look on the atomic structure, how this subatomic level. First we look on the subatomic level, how this components are arranged in an subatomic level. Then we will study the crystal structure, how these atoms are or molecules are arranged in crystalline manner. We will study about that. Then we will study the ideal crystal structure, but crystal have some defects and which control the properties of the material. So we will study the defects on these crystal structures, and this will be followed by diffusion, phase transformation, and different micromechanisms. These are the different micromechanisms to develop different microstructures. And we will study about diffusion and the phase transformation of the crystalline materials. And then we'll study various strengthening mechanisms like allowing to alter the properties of the materials. Then finally we will look on to the mechanical behavior of material. We will look at the plastic deformation, creep, fatigue, and the fracture of the material. Also, we will touch in the area of composites, superalloys, intermetallics, marine steel, titanium, and ceramics, etc. All these things are high-end materials. For example, or missile or cryogenic engines. In those areas, we need sophisticated material for that application. So, for example, these superalloys or high strength materials it's a high strength material. They can withstand high strength in high temperature. So such type of material can be used in this missile and rocket propulsion area. So these high-end materials are commonly used in higher-end engineering applications. So this is the outline of our course. From the next lecture onwards, we will study about subatomic levels, how the atoms, the components in the atoms are arranged, and we will give a brief review about atomic structures and the bonding of the atoms, like primary bond and secondary bond, and their mechanical properties. We will cover these topics in the